Hello, my dear students. So, today's question is the question in which 99% students does mistake. Yes, I have observed it. Every year I discuss this question, right? So, whenever I give this question to students to solve, then I have observed 99% student does mistake. A very important question of topic kinetic theory of gases, and from Pathfinder check your understanding question number 16, right? So please go through this question in detail. We are going to discuss its solution, right? Okay, so first read this question. Give yourself at least 2 to 3 minutes. Temperature of upper and lower surfaces of plane horizontal sheet of area S are maintained at temperature T1 and T2 respectively. So diagram of the question is not given. That you need to think by yourself. Air pressure on both sides of the sheet is P0. Ambient temperature is T0 and acceleration of free fall is G. The air molecules strike a face of the sheet with the kinetic energy that corresponds to ambient temperature and bounce off the face of the sheet with kinetic energy that corresponds to the temperature of the face of the sheet. What should the mass of the sheet be so that it stays floating at a level height in air? Right? So that is the question, beta. You need to understand language by yourself, okay? And try to think what they are asking, right? Okay. So pause your video here, at least for 2 to 3 minutes, right? And now we are going to discuss the solution in detail. So first of all, from where what they are asking that mass of the sheet so that it stays floating. So stays floating. So the idea that is coming in our mind is we have to do some kind of force balance. So idea is pretty much clear here. The approach has to be we need to find net force on the sheet. Okay, the net force on the sheet is required, right? So like see, you can see this diagram. So on the sheet, upper surface is maintained at temperature T1, lower surface is maintained at temperature T2, and here one more thing is written that ambient temperature bounce off the face of the sheet with kinetic energy that correspond to the temperature of the face of the sheet, right? So now we know kinetic energy is directly proportional to temperature. It means they are trying to say molecules are striking with velocity V0, right? And V0 is corresponding to temperature T0, and they are bouncing off with velocity Vt1, where Vt1 is a velocity corresponding to temperature T1, right? Means after striking, what is going to be velocity of the molecules? Okay, so now if any molecule is striking on its surface, we know what will be the expression of thrust force. The thrust force, we know it is rho a v square, right? So here direction properly we have to see because that is a mistake alert. So I have seen that student does mistake in sign convention only, right? So if I am saying net force F1 is acting by the molecule which are striking on the upper surface, then when the molecules are bouncing off, they are exerting force in the downward direction. When these molecules are striking, they are also exerting force in the downward direction. So that is our mistake alert, right? But no problem. Even if you are taking negative, your answer will be correct. Okay. So here it should be positive sign first of all. Okay. So rho s v t1 square plus rho s v t0 square, that is force on the upper surface. Force from the lower surface will be rho s v square plus rho s v t0 square. Okay. So net force we can write like this. So that is net force exerted on the plate. Okay. So now we know that these velocities, it's not like some molecules are striking in a particular direction. That are gas molecules, and we know their random nature, right? So if I want velocity in any particular direction, say you can write like this: Vx bar whole square, Vy bar whole square is equal to Vz bar whole square is equal to 1 by 3 Vrms square. That already we know. Okay. So these velocities we can write like this. So a particular velocity in downward direction I can relate with the RMS velocity, right? So I'm writing Rm velocity corresponding to T2 temperature, RMS velocity corresponding to T1 temperature. Okay. So now pressure expression we know P is equal to rho RT by M, and rho is M into N. So what is N here, beta? So N is number of molecules per unit volume, means number density. Okay, so P is MnRT by M. So now I am substituting here net force as Mn by V into S. Now here the problem is which is our crux point of the question also. So that number density I am taking here, it should be half of the actual number density, right? Because in the expressions I am applying thrust force formula, means the molecules which are going downwards. Okay. So in random motion, molecules are moving in both directions, downward as well as upwards. Okay. And I'm writing force corresponding to downward motion only. So that's why I need to write number density as half of the actual number density present. Okay. So here I'm doing it. So Mn by 2 I should write. Okay. Then net force I'm getting this expression, which is Msg. So Ms is equal to this finally expression we are getting. Okay. That is our right answer. So anything if it is not clear, please tell me, beta. Don't worry. Okay. You can send me message. Right. Okay. Thank you.